Hello guys, I am Dr. Marcelin Inidabo. Hope that you are doing very well. Welcome to this video. I will be presenting you today the test bench that I have developed with a partner, Mr. Amadou Sagna. So may he rest in peace because he deceased during this year. Uh, so um, in this video, I will be presenting you a test bench for the speed regulation of a DC motor. As I was saying that we have developed together. And then, so you have the test bench here. You can see that there is a DC motor on the top here. Okay. This is a test bench that is not it is light, it is 60 and 50 grams. You have different elements on the top of the test bench. You have here the press button. Okay, if you press button, you can see the test bench is rotating. We will come back on this later. So here you have the Arduino, okay, and then on the top of the Arduino you have the power card, and here you have the two sensors and a relay here. Sensors, voltage sensors, and a relay here. So this is connected to the computer by a USB cable, and then you have also a cable of um, 12 volt that is coming, because if you use only the USB cable, you will have only 5 volts for the motor and you will not be able to reach because you will some given set points, meaning that voltage as input and speed in radian per second as an output. So you need more energy to reach, of course, more higher speed velocities points. Okay, so with this test bench, you can work in open loop and closed loop. And as you can see, there are different wires on the test bench. With these different wires, these are connecting wires. Once it is done, you don't need to touch again your test bench. You can work on open loop as on closed loop, and just by loading different programs that you have. Okay, so this is very, very important to see and to understand. So with this test bench, what you can do is that you can flash your program through Arduino. It is an Arduino-based test bench. And as I was saying, on the open loop strategy, you are able to just flash the program. And what is the principle is to take a certain percentage of the input voltage. In this case, it is 12 volt. You use the half of 12 volt, or you use a quarter of 12 volt, or you use the eighth of 12 volts. And then with this available voltage that you will give to your DC motor, you will have a specific rotational speed of your DC motor. Okay, so on the open loop, for the open loop application, you can just make a table on your paper, meaning that, and then you have a point, a first data that is the input value, a voltage value for your DC motor. And then at the same time, you measure the speed of your DC motor. And then this will give you a cartography of performances of your motor according to the voltage as input and the rotational speed as output in radian per second. So why this is important? It is because when you will be working on closed loop, you will be deciding which speed that you want to reach. And then if you want to do that, you can take the speeds that you reached at closed loop and compare the voltage value that will allow you to reach that speed and to have an idea if, for example, your PID controller, that is the case, that is the controller that we will be using, you can check if that PID controller will give you the correct value of voltage as you had in the open loop period, in order to know that if you are reaching the good speed through the same voltage. This is a good exercise to know that at the beginning as open loop, the operator will give through the program a given voltage that is corresponding to a given output value of speed. And then at the closed loop now, the operator will just fix the desired value and the controller will give the correct voltage to let the motor reach the right value. This is very important to show the coherence between the different values. So now let's now go to do the tests. Okay, so here you can see that I already download the open loop program. And then, as I was saying, if you want to take a given percentage of the available value of voltage that is 12 volt. For example, if you do this, you can read here, this is the voltage, you can read the voltage here, okay? And then this is 64 divided by 256. It is a certain percentage. It is 1/4 of the 12 volt, okay, around 3 volts, and you will be having a corresponding value. So let me now press on the button and you will see what will happen. So you can look also here. These are curves that you have here on the left. Let's go for the picture. So here is the test bench, okay? As you can see, I can press and you can see that the speed has moved here and the motor is rotating. If I press again, you'll see that the speed goes up here and then the motor is always rotating with the higher speed that you have here, okay, greater than 500 radian per second. And then if I press again, according to my program, I am describing these different steps of the program. So now I touch this value and now I am here. If I press again, I will be here. Okay, you see the speed is going down and then finally 0. And after, I can move on another direction, always through the same principle. So you can see here, the speed is going and then I press again. I reach this position, okay? So now if I press again, I will have the highest speed in the negative, in the counterclockwise way. And then after I press, I come back a little bit to 0, okay? This is how it works on the open loop side, okay? Because what I just put is I just introduce different values of voltage to reach the different speeds. So now I am going to the open loop to the closed loop now. So let's go to the closed loop now. If I choose, this is the open loop. So if I choose the closed loop program, the closed loop program, I choose this one. Okay. So as I said to you, going from the open loop to the closed loop, you don't need to change something on your test bench. Any connection, anything, you just keep it as it is from the open loop. And then you charge your closed loop program. Okay. So your closed loop program is charged on your test bench. And then if I come again with the test bench, I can show it to you. Now what we are going to do, so the parameters are here. Okay, the PID parameters are here. We are using the PID controller. And then, but the derivative is equal to 0. So it is in fact a PI controller. These controllers values, you will be able to adapt them according to your calculation. If you want to modify something on your program, it is for free. But I advise you to keep first the original values, and then from them, you will be able to reach what you want. So our set point, first set point is 100. So you see that this in green here, it is 100, and then you can see the speed is, the mean value is around 100. And then if you want to read the values here, You see the voltage. Here you see that we are between 117, 78, etc. And the corresponding voltage is here around 3 volts, okay? If I press again, so you see that the green is at 300, as you can see here. And then the tracking value, the output value is around the desired value, the desired speed value, okay? Let me press again, we go to 500, and then you see that we reach 500 radian per second, as you can see here, okay? So this is the rotation, okay, of our DC motor. This is, now I am on the closed loop, and you can see that from the open loop to the closed loop, it goes very fast because I just charge the correct values, and then I am okay on the speed. Now, if I press, I go to 400 here, and then you see that I reach it also. If I do this, I go to 200, you see that I reach it also. So let's go for the negative, the 100, you see also on your screen here, I reach 100, and then 0, okay? So now I reach a 0, and then now we have to go to the negative, to the counterclockwise. So let's go, you can see here I reach the value. Here, if I refresh, you can see the values, they are here. Okay, around 200 here, and the given voltage is around minus 5 volts. We are going to minus 300. If I press again, you see that the regulation is going very well. And then here the voltage is around 7 volt. And then you can see the value of the speed here. So sorry for the display here. I don't know why it is sometimes freezing, but you can see that the correct values are here. Let's go for the more negative again. So we are going now to 400, minus 400. If I refresh here again the display, you can see the voltage is around 8 volts, and then the speed is here around 400. 500, we reach the value. If I refresh here, okay, you can see that we reached the correct value. So this is to show you that the tracking with the PID controller is going very well, okay? So this is for the closed loop. We have seen the open loop. We have seen also the closed loop. So if you want to make your modifications, I will not touch this program today, but you just come here, make your modifications, flash again your program, and then you go to do this exercise again. Okay. Let me just show you something. If I say here, let's put 0.2 instead of 1 here. And then let's flash. Here, the value of the integrator is very small now. Okay, so once we finish the flashing, if we press, okay, the motor is going on. So you can see that it takes a very long time before it reaches the value, okay? You see here, you can see here. Before the integration goes up, and then here you see that, you can see that there is, if you take the mean value, there is a kind of, how you say that, a static error, okay? But it will take a long time for the integrator to charge. Okay, if you do this, you see that it is going down, but it takes too long to reach the set points, the desired set point. Same for this one, etc. So you don't have a controller that is acting efficiently. There is a kind of lag on this controller with this new parameter. Okay, if we come back to the first values that we had here, meaning multiplying this expression, this value by 1, and then when we flash it again, it is going on. So the flash is going on the test bench. So you can see that this is a kind of rapid prototyping tool. Okay. If I press, I reach the goal relatively quickly according to the other one, as you saw. Okay, it comes very quickly. And then if I do this, I can see that I can reach the different points. So I let you, this is the test bench that I wanted to share with you. And then, of course, I am selling this test bench. So you contact me, and then I will give you more details about this. Thank you very much. It is an Arduino based, and if you like this video, if you enjoy this, please, I invite you to share and also to like, and then subscribe on my channel, please. And I hope this video has brought you very interesting information. So if you have any question, as I was saying, please join me, and then we will be able to share together.